next block of modern periodic table, that's p block elements similar to s block element. To understand this well, we must understand those elements whose last electron available in p orbital of outermost cell. Outermost cell. Properties of f block element, p block elements mean very simple is that the elements last electron will be available in p orbital of outermost cell. So these elements belongs to p block element, and to understand about these elements we must note the properties of p block. This is easy to understand about the elements those who belongs to p block. Right now we should start. The electronic configuration of outermost cell is ns2 np126. The electron, last electron would be represented, n can get variation in the p1 to 6 electron will be there for p block elements. So this is the electronic configuration of outermost cell ns2 np1 to 6. Now second property is elements have electronegative nature for, or these are non-metals. Very simple is like you can say here 3 examples you can see, like oxygen, like nitrogen, like fluorine, chlorine, etc. Now you see chlorine, let's 17 having 287, it will have 1 electron, it converts into Cl minus. These are the examples. Nitrogen, you see 25 minus 3, oxygen 8, 28, 26 minus 2, F 27 minus 1, 287 minus 1. Means they need 1 electron to complete their octet, and this actually nature is electronegative nature and acts as non-metal. Non-metal means simply you can define if the last most orbit have the electron numbers 5, 6 or 7, termed as non-metals. Now element shows electrovalency like in NaCl, covalency like in Cl2, etc. Forms acidic oxides like you can say Cl2O7 like. Examples are there. Elements are more reactive. This is simple to understand that NaCl, KCl, NaF, Br2, Cl2, whatsoever compounds you will get, mostly you will find this O2, N2, etc. Means these are too much reactive, and in such a way you can understand simply the properties of p block elements, and these are electronegative in nature and these are non-metals. To understand this well, now you can see one example like electrovalent. NaCl lets you understand. Here Na have the electron 281, Cl have 287. This electron can be transferred here. What will happen? It will convert into Na plus, this is the bond, Cl minus. This is just crystal clear. Example is Na plus Cl minus. This is 281 losing electron, 287 accepting electron. Both are having the condition here 288, 28, and it will show 288. This valency is actually electrovalency. Also shows and proves the things like electronegative nature of this, non-metallic nature of this, etc. And these are too much reactive. By this way we can write the properties of p block elements. If the element belongs to p block, these properties would be common. So students, thank you. We will start next block, D block element, and I will understand the properties of element those who belongs to D block in next lecture. Thank you students.